Hey guys, today we're going to graph equations of lines, only lines, linear equations. Cool slide right here. The key word here is parent functions on the slide. The parent function for linear, I'm going to talk a whole lot about parent functions as we go on through the year, but just a quick introduction right here. The parent function is like, all the kids from the line family come from this right here. They all come from f of x, which remember is really y, equals x. When you have that function, the y-intercept is 0 because, as you remember, there's nothing there. The slope of the line is 1 because there's a 1 in front of the x, and that's what it looks like. It really goes through, we'll teach it this way, it goes through 0, 0, 1, 1, 2, 2, 3, 3, because if you look at the equation, y equals x. So if we're x and y are equal, it goes through -1, -1, -2, -2, -3, -3, and of course 0, 0, and that's why the y-intercept is 0. We'll talk a lot more about that as we go on, but please remember that is what is called the parent function of all lines. All right, I already graphed these for you, but I wanted to show you what I'm talking about here with parent functions. I want you to compare these two to that line right there, which is the parent function. Look at this one, y equals 2x. When they put a 2 in front of the x, what happened is all the points got stretched vertically by 2. Like that point right there on the blue line, what's that? That's 3. And by the time it got up here, it's at 6. The one right here was at, you can't hardly see that. It was at 1, got stretched up to 2. So everything got stretched up 2. Sorry about that delay there. This right here, y equals x plus 3, what happened is the whole line got shifted up 3. Like from here, up 3. From here, up 3. From here, up 3. So when they added 3 at the end, it got shifted up 3. When they put a 2 in the front, every point got, basically all the y values got multiplied by 2, which made it get a lot steeper. Okay, I'm going to show you like 3 ways to graph today. The first one's slope-intercept form to graph an equation, and this is the kind you're probably most familiar with. Slope-intercept form means you solve for y. You get y isolated by itself. You identify the y-intercept, which is b. You get it? Y-intercept b, but y-intercept, I don't either. But that's the point over. You just put that point on the y-axis. Then you find the slope m, slope. And then you use that using rise over run to find the second point. It only takes 2 points to make a line, so you just draw the line through the 2 points, and you got it. We're going to try one like that right here. It's already in slope-intercept form. You know that because you have the y by itself. So the y-intercept, this is the b right here. This is -1, so I'm going to put a point at -1. You can see it right there. The slope, remember that's rise over run. So it's negative, and you know what that means. It's going to fall from left to right. I'm going to go down 2, right 3, down 2, right 3 to right there. Also, as long as you go one of them negative, you're okay. I also could have gone up 2, left 3. As long as, you do one negative, one positive, you're fine. I'm not going to be able to connect these very well. I'm going to give it a shot. Connect all those points together. That's actually not bad for me. And there you go. It's graphing a line using slope-intercept form. They're going to give you, a problem-solving skill with slope-intercept form. It says the body length, y, in inches of a walrus calf can be modeled with this equation, where x is the calf's age in months. So graph the equation. So it says 42. Oh my goodness. I'm going to say we're going by, let's make this. Let's go by 7s. 7, 14, 21, 28, 35, 42. So 42 is right there. And the slope is 5. So I'm just going to go up a little bit and over 1. So the equation is going to kind of do this kind of deal. It's going to go right through there. That's pretty bad. Then it said describe what the slope and the y-intercept represent. Well, the y-intercept represents the 42, which is the y-intercept, represents calf's length when born at age 0 month. So when it was born, it was 42 inches. The slope describes how many inches, the slope is 5, how many inches per month is growing. So per month growth, 5 inches. Remember, rate of change from the other day. Slope is rate of change. I use the graph to estimate the body length of a calf that is 10 months old. My graph's pretty terrible. The best way to do this is probably to stick the 10 in the equation right there for x, and you would get y is 5 times 10 plus 42, which would be 92. You'd expect it to be about 92 inches. which is really big. All right, a second way to graph things, use standard form. This is my favorite, instead of having to put it in slope-intercept form all the time. It says that identify the x-intercept by letting y equal 0 and solving for x. Then identify the y-intercept by putting 0 for x and solve for y. And then because you have the x and y-intercept, you just draw a line through those 2 points because those are your 2 points. Tomorrow we're going to call this cover. You'll see what I'm talking about in class tomorrow. Graph 5x plus 2y equals 10. So what I'm really going to do is I'm putting a 0 in for y, which means really I'm acting like y is not there, hence the word cover. Tomorrow in class we're going to cover it up. And then I'm going to solve for this. 5x basically equals 10. So it crosses the x-axis at 2. So I'm going to put a point at 2 right there. Then I'm going to do the same thing the other way. I'm going to put a 0 in for x, which means that term's really gone. So that leaves me 2y equals 10. 2 goes into 10 5 times, so I'm going to go up to 5 on the y-axis, my y-intercept. So there's my 2 points. I'm just going to connect them, which, you know, freehand, this is crazy. So going right through, almost got it, right through the 2 points. But that's all you do. So really, standard form, really pretty easy. And standard form means, by the way, x and y are on the same side, and also no fractions nor decimals. All right, horizontal vertical lines, the last thing today. Horizontal line is when you have a y only, because it must cross through the y-axis. Think about it. If you have the y-axis and the x-axis, a horizontal line has to cross through the y-axis somewhere. That's what this is saying mathematically. And if you have a vertical line, it must cross through the x-axis somewhere. So it has an x. So vertical is x equals a number. Horizontal is y equals a number. It's kind of backwards of what you think, because you kind of want to think it goes like the axis does, but it actually goes through. It has to intersect that axis or go through that axis. Okay, last one here. The first one, y equals 2. The way I do these is I think, okay, it has to cross the y-axis at 2. And because y equals, that means it's horizontal, so it's going to be a horizontal line right across y equals 2. The second one, x equals -3, tells me it's got to cross x-axis at -3, which means it's got to be vertical. It's going to go right. I kind of messed that one up there. Right through -3, just like that. And that's it. So 3 types of ways to graph today. And don't forget that parent function detail. And hopefully this is a review for you. If not, it's okay. We'll work on it in class tomorrow. Graph a bunch. So be ready for that. See you then. Look forward to it. Bye.